Anion gap in diabetic ketoacidosis. First of all, what leads to DKA? Everyone must have heard about what type 1 diabetes is, right? It is a disease that is related to insulin. We probably already know the best treatment for this health condition, but how do we tell if something is not functioning? Let's see. Let's say you eat carbs to gain energy. Your body breaks down the carbs into sugar, which then goes into your blood. Unfortunately, the cells can't use the sugar in the blood for energy due to insulin deficiency. When this happens, your body will seek out alternative sources in which they will use fat for fuel instead. This can put your body in a state of diabetic ketoacidosis, also known as DKA. So what is DKA? DKA is a serious complication of type 1 diabetes. This happens when the blood sugar level is very high and acidic substances known as ketones build up in the body to dangerous levels. Wait, what are ketones? Ketones are compounds produced by the body as an alternative for energy during the process of lipolysis, where the fats are broken down into fatty acids. Then the liver turns the fatty acids into ketones. Although ketones can be used by cells for energy, it can also make the blood acidic. So, what are the symptoms of DKA? They may have excessive thirst and frequent urination apart from feeling tired and weak. How to diagnose DKA? DKA can be diagnosed using a few ways, including taking a blood test to measure the anion gap. What is anion gap? It is the difference between primary measured cations, sodium and potassium, and the primary measured anions, chloride and bicarbonate in serum. The value of anion gap is obtained by using the following equations. However, the first equation is commonly used because the amount of potassium is low in serum. Then, what is the purpose of anion gap? It is used clinically to trace or detect the presence of metabolic disorder that affect electrolyte balance. It is also used for the assessment of quality control in the laboratory, and it is used to diagnose disorder. Anion gap works by measuring the unmeasured electrolytes in the body. Law of electron neutrality is applied, which means that the value of anion gap should be 0, where the sum of cation concentration and anion concentration are always equal. However, normal range of anion gap should be 7 to 16 milliequivalent per liter. But why does anion gap still have a value instead of 0? This is because the normal range reflects electrolytes physiologically in the body, including normal solute. From the equation, sodium and potassium account for majority positive charge. Unmeasured anions may be ignored. The one to be concerned here is when the value is more than normal range because of pathologically anions. How is anion gap performed? It is performed by using ion selective electrode ISE. ISE measures the electrical potential difference between two electrodes in the sample solution. The first electrode is known as reference electrode, while the other electrode is known as indicator electrode, which has the specific composition of the electrode's membrane. Different composition of the electrode's membrane measures different type of electrolyte. This principle concludes that the electrical potential difference is proportional to the amount of electrolyte in the sample solution. Next, how is the sample collection and handling done? In DKA cases, the patient sample such as non-hemolyzed serum or heparinase plasma is used in ISE procedure. This equation is used to find the anion gap, which technically should be in between 7 to 16 milliequivalent per liter. There are some of the interference that can cause false result of the anion gap. First, when the sample has high amount of proteins, it will build up on the ISE membranes and lower the selectivity. Second, a hemolyzed sample will cause the potassium ion to increase. A false increase in potassium will result in a false measurement for the electrolyte. Third, measuring the sample using an indirect ISE method can lead to an exclusion effect, which will lead to a false decrease of sodium ion that is known as pseudohyponatremia. Moving on, how to interpret the laboratory findings. A display of high anion gap results from decreased unmeasured cations and increased unmeasured anions. Occasionally, there will be a result of a low anion gap. This is due to decreased unmeasured anions and increased unmeasured cations, but it is mainly related to detect analytical error in the laboratory. What are the causes and effects of high and low anion gap? If the results show a high anion gap, the individual may have acidosis, which means that the level of acid are higher than normal levels in the blood. This happens when there is a dysfunction of the lungs or kidney. On the other hand, if the results show a low anion gap, it is due to a few abnormal conditions. However, retesting is often done to ensure accurate result, as it is commonly associated with analytical error. With that being said, how does DKA relate to high anion gap? As DKA is categorized as metabolic acidosis, excessive ketones are produced for energy with accumulation of keto acids, which account for the increment of anion gap. Other than that, the failure of renal in reclaiming bicarbonate ions leads to low levels of bicarbonate ions in extracellular fluid.